Hi, this is Paul Neale at Penn Productions, and today I'm going to do a quick tutorial on how to use an XML file to be able to build project folder systems. I want to cover some basic ideas first to get an idea of where we're going with this and what's going to be working. So the idea is going to be that we're going to be using a tool that is going to read an XML template that's going to outline what our folders look like, and it's going to build that folder structure for us on our hard drive. So first, let's cover a few of the needed tools that we're going to need in MaxScript to be able to do that. First off, right at the top here, we've got getdir maxroot, and that returns the maxroot file. This is one of those things that you can use to get specific file folders and whatnot within Max. So getdir will return with a hashtag in front of certain names different folder systems that are always consistent. Now, if you actually run it, if I run it here with without all of root selected and go Shift Enter, you'll see that it actually gives me a runtime error. But that's all right, because what it actually does is feed back all of the different names that you can use to be able to get all the different folder systems. So that's one way that you can get folders inside of Max if you need it. You can also do things like getting the current directory system that Max is currently in and was last opened in. So in this case, it's my Xml Project Manager folder where I'm running this tutorial from. You can go get things like the system window folders and whatnot. So you can use different pathing systems within MaxScript to be able to get and work with certain folder systems if you need those as base points to start working with. A couple other commands here is going to be one, get files, get directories, and then of course we're going to use make directories and delete files as well, possibly if you wanted to remove anything. So get files is going to be pretty simple. Get files is going to be a tool that's going to get all of the files in a given folder system. So let's go and grab a folder directory system right now. I've got one listed here that we're going to be using later. So I'm just going to cut that and paste it back over. So I'm using an @ sign. The @ sign basically says this is a file path. If you don't use that, we can run into problems when we have certain key combinations happening here with escape characters. And right now you'll see my color coding has all gone wonky, and it's probably because of the escape characters. So without the @ sign, we'd have to make sure that we used escaping in every single one of the locations there. So you can see that as soon as I add the last one, all that color coding went away. And the reason being is that \quote is actually a quote inside of a quote. So we always have to make sure that we've got double backslashes. Or again, if we're just putting the path in here, we can use the @ symbol in front of it. Now, you can't use the @ symbol if you're going to be building strings together and concatenating strings together. So you need to be able to then use your double quotes if need be. So I'm going to just run it this way. I'm going to say get files, and you'll notice that it actually returns nothing whatsoever. And it returns nothing because we said get all the files by this specific name inside this folder, because right now, if you notice after our last backslashes, we have nothing listed. Now, if we use the wildcard star, you'll see it returns an array of all the files that are currently in that folder system. And if I just say print, it might just make it look a little easier for us to read. Just put that in quotes, and there's the 4 files that I currently have in there for this example. And so we could also say let's only get the .ms star.ms files, and then it returns only 3 of them to me, or the XML. And of course, it only returns 1 file, which is what I have in there. So you can go and get them. Now, we can also use the get directories. So I'm going to grab that same path here, and I'm going to place it in there with the quote on the end. Same thing's going to happen here. Get directories is going to return an empty array for us, because again, we're not saying what file name. So again, we'd still have to put the star in there. In this case, it's still going to return that because I don't have anything in there. So I'm actually just going to pull off the last folder, and you'll see that now that it actually has a bunch of folders inside of that folder system, and it lists all of those. So we can go and get all our directories, we can go get our files and work with those. Now we can also make directories. So I could go, for instance, and grab our path again and make directory test, we'll call it. And I'll just end that off. And I'll run it. It returns true, saying that it did indeed do that. And so again, let's go in and grab all of our directories again in that folder system. And you'll notice we actually have one called test that's been returned. So I just built a directory structure in there. Again, we can go and check that. We can see that test has actually been added. So I'm just going to delete test here and just remove it out of the system. And let's go and add something a bit better. Or, you know what, I'm going to leave it and I'll let the file do it. Delete file, same sort of thing, and a whole bunch of others, so go and look at them. Now, get save path is going to be one that you might want to use as well. And I've just copied and pasted this right out of the help file, and of course it doesn't run this way because it's got all the help captions around it and whatnot to tell us what we need. So get save path will allow us to be able to put things like captions in and whatnot. Now you'll notice that we've got these square brackets and greater than less than signs. These are mystery to some people in the help file. What the square brackets mean, that is, we don't have to actually add any of this. So if we took get save path, open close around it, what it would do is just open us up a file browser or folder browser, and it wouldn't actually have any specific heading on it or anything. It would also open in the last used place. So that get save path will do that. Now we could say, let's use this, get rid of those square brackets. So that means we didn't have to pass caption to it. But if we do pass caption to it, we have to actually put some sort of string in here, and that's what the greater than less than sign says. It says that we have to include this. So we could go and put this is a test. And again, the initial directory, same thing. What we might want to do is go in and open it in a specific directory folder. For instance, I might want to go and open it in // and open it in that folder, and now it's actually opened on my D drive, and looking at that D drive with this as a test as a header. So looking into some of this is certainly going to help you. Let's talk about recursion now. So one of the things we're going to have to do is we're going to have to recurse folders. And what that basically means is we have folders inside of folders. So if we look at my master classes folder here, if we were to dig inside of this with MaxScript, we have no idea how many folders there are. We also have no idea how many folders are in the folders, are in the folders, are in the folders. So we can't write a single straight up function that's going to linearly sort of plow through all of it one step at a time. We have to write something that's called recursive. So a recursive function is a function that is going to call itself. So let's take a look at what we've got here. I've got a function, and I've called it recurse folders, and I've got a single property being passed here called fpath, so file path or folder path. And then what we do is we're going to just check and make sure indeed that path does exist, and does file exist, fpath, so is it valid? And just in case when we start off we passed it something incorrect. We're going to go and use that command that we found before in the last page here called get directories. And again, my fpath is going to be actually get dir max root. And if I check just that chunk and run it, what you're going to see is that it's actually feeding back a path, and it is not feeding back a star on the end, of course, because it doesn't know what to that I'm going to be searching with it, for instance. So I have to say fpath plus our star and add our star on. Now, because this had returned a path, Max somehow magically knows in the background that it should be double backslashed because it was built this way. So there is some magic voodoo going on in the background, because you'll notice that there are no double backslashes here, but it'll still know that it's a correct path. So once we get all the folders, we're then going to run through all the folders. So I'm just doing a basic for loop for d in dirs do. So there's our dirs, all our folders. So loop through all the dirs, and let's actually print them out. Now I'm just going to quickly comment out this last line here, and I'm going to run this. And so evaluate it all. So what it's just spat back out at me are all the folders that are directly inside of Max 2015 that I'm currently running. So you can see that it's actually spat out every path folder that is directly in that. But we're not getting all the subfolders and the folders of the subfolders and so on. So what we want to do then is we want to actually call the recurse function again from within itself. Now if you remember the first time we passed recurse folders, we actually passed it the root where we wanted to start. Now when we call it, we're passing it one of the directories that we're currently in and we've arrived at. So we've arrived at this folder here called UPI. Let's pass it back and let's run recurse folders again on that folder and let's find all the folders in it. So now I'm just going to clear that. If I run this entirely and let the recursion happen, you'll see that essentially Max script is feeding back, and it's taking a minute because it's going through all of them. It's feeding back every single folder that's inside of and downstream of the Max root folder for Max 2015. So there's all the folders that are being kicked back. So recursion is something we're going to need. And the reason we're going to need recursion is we're going to be using this XML template. So what we're going to do is we're going to create a function that will recursively search through the XML file. And each time it steps inside of a set of tags, it's going to find the tags that are inside that tag, and it's going to find the tags that are inside of those tags. And what it's going to do is it's going to actually build us a directory structure that mimics this XML file. Now how's that going to happen? You say this is just an XML file, it's just a big string effectively. Well, when we read XML using .NET, each of these tags becomes an object, no different than a folder does on your hard drive in a sense. It becomes something that has properties and methods and can have children as well. So we can read them in and we can say this item here, this root node, has children that are named folder, and they have properties of name and they're given names. And each of those have children and so on. So we can use this exact same recursion method to actually recurse the XML file. Now let's take a look at actually reading and getting at your XML files to begin with. So this is also on my website in the .NET tutorials area. So what we've done is we've had to have made a variable, and we're going to start up an object using .NET object. So everything in .NET is an object. Everything, instead of just having a value, say 10, like in MaxScript, we actually have to use an object that represents and holds the value 10, for instance. In this case, we're going to be launching here the .NET object that's called system.xml.xml document, which is actually going to create us an empty document. So basically a placeholder right now. If we check XML document, so I want to evaluate that just with Shift Enter, you'll see that it returns us back a .NET system XML document. We can then use many different commands like show properties XML doc, and it'll give us back all the properties of the XML document. We can also show methods, and we can get back all of the methods. And one of the methods here is actually .load. And this .load allows us to be able to pass it in a string. So we've got .load, and we can just pass it in a file name in this case. And again, like I said, everything in .NET needs to be an object. So in this case, we have to pass it a system.string object that contains the file name. Now, luckily for us in MaxScript land, it's been made very easy, and MaxScript knows to do certain conversions for us. So it'll convert integers into system ints. It'll convert strings into system strings, this sort of thing for us. So Boolean objects will get transferred over as well without having to make these objects and go the long-rooted way through .NET. So in this case, what we're going to do is we're just going to pass it a file name, and that's this one here. So what I've got is my XML template that I've saved here, and I'm just going to run this line, and you'll see XML doc.load. And if I load that, it just returns undefined, but it didn't error at least because I checked to make sure. Does file exist is one I should have put on here. As well, so we could actually use exist and pass it a path, for instance. And we could check and make sure that indeed it exists or does not exist in that path. Now I don't have the proper file name in there, so I'll call it XML template, and I must have that wrong. No star. There we go. True. So I know that it exists. So again, that's something I would have wanted to test it before I passed it in to try and load it. So now that I have it loaded, we can actually go and use our show properties on our XML doc and get a certain things here. One is going to be called document element, and a document element is the very first document element. So if I actually check .document element and run that, it's giving us that first element, a document element. So in XML, unlike in HTML, can only have one root element. It doesn't need to be called root. You could call this anything you want, but that's one element that's directly left justified or is basically the root of the tree of our system here. So it's returning that one. We could actually say .name, and we could find out it's called root. Now I knew .name was available to me because if I asked for the XML document element, the document element is an object, and I can do a show properties on it, and I can find out all the properties. And in this case, I can find out if there's inner text or inner XML. I can find out whether or not there are child nodes, for instance, which we're going to need to do, and we need to loop through those. And we're going to have to be able to go through these. And here's the name property that we were just using. So we're going to be able to use this information to be able to sort of dig through and find out what's what. So let's start writing something. And this is, oh, and by the way, I've got location here as well. And this is where we're going to write it back to. And again, I've just hard coded that as a path. So let's start writing something. Let's say function create directories from XML, we'll call it, let's say. And we're going to pass it the root XML system here. So we're going to say root. And let's actually just give it an initial name property. And we won't have to pass this. This would be something that you'd want to have the user be able to do, and that's pass in some sort of project root name for it and set that up. If you notice that in my XML file, I'm listing names for each of the folders, but not the root. I haven't put that on there because that should be something that is determined by the user effectively. So let's make sure we go and call that and pass it the root. So what our root is, in this case, is going to be our document element. So we've gone and got that document element, and we know that is the root element that's being passed back. So if I were to check this, I would know that is what I expect it to be. So let's just do, for instance, a print root.name here for sake argument so we can see it. And let's give us a project root name here. We can pass that in. We start this my project, for instance. So if I were to run this now, you'd see it says root root. It says root root because the function returned root and it also printed root. So we could say return false if we wanted, or just put false at the end, and now it'll say root false or root true, however we decided we want to do it. So now that we've got that, what we want to be able to do is we want to be able to get all the child nodes and start doing a recursion. So just like a recursion here, we want to make sure that indeed we can go and get all the directories. Now we're not getting directories in this case. What we're doing is we're getting these child nodes, and we're going to loop through all the child nodes. So we're going to go and grab all those child nodes. So let's just make a child nodes equals, and we'll sort of do it long-winded, and we'll say the root dot child nodes, and that returns all the child nodes. So we can say for C in child nodes do, print C. And I'm going to run this. We're immediately going to get an error. And the reason we get an error on this is it says there's no map function for child nodes. We are looping through a .NET array here, and it doesn't like going through it in this method. We have to go the long-winded route. So we have to go for I equals 0 to child nodes dot count minus 1 do. And then again, might be something you're not used to seeing in MaxScript. Usually you'd say for I equals 1 to child nodes dot count do. Well, MaxScript is about the only language that I know of that isn't a zero-based language for arrays. So the first node, the first object, or I should say the first item in an array in MaxScript is item number 1. In just about every other language, it's item number 0. So we need to start counting from 0. So in this case, what we're going to do is we're going to say from 0 to child nodes dot count. And this is where that oddity comes in programming. The dot count will tell you there's 10 objects, but the 10th object is actually object number 9 because the first object was 0, not 1. So we have to say minus 1 to loop through them. So let's actually loop through that. And I'm going to say I. So you notice when I run this, we get another error. No get function for XML child nodes. Well, as it turns out, we can't directly access arrays quite the same way in .NET as well. We don't just stick the index after it. There's often a little bit something else we need to do. So let's actually just go show properties. And you'll notice that there's a count, which is the count that we found. But there's this item of, and the item of will tell us which item it is. So we need to say print dot item of I. And now you'll see that correctly feeds back our information to us. So those are the 3 elements that are inside of that. So if you look at our XML file, what we're getting then is the root, the folder, and the folder. Let's go and get the properties from these and print these out at the same time. So let's make sure we get those. So this is the folder itself, or sorry, this is the element itself. So I'm going to call this element equals. So that's the folder element, or maybe I'll call it folder to make sure it's easy to see. And then let's get a property here. So let's print this out. And let's say folder dot get attribute name. And you'll now see that we're getting assets, renders, animation. We got root printed because we printed it up top. So let me just comment that for now. So what we're now doing is we're stepping into each one of these. We're getting the name attribute, and we're checking the name, and we're listing that name back. Now, when you ask for attributes and whatnot, it's name dependent, or case sensitive, sorry, I should say. So we need to be careful here. MaxScript is not case sensitive. Every other language is. So we need to make sure that we pass this. We don't pass a capital N, for instance, and then wonder why we're not getting what we expect. It's because there's no attribute called name with a capital N. So I'm just going to use the lowercase there. So this is the folder name. And you know what, I'm going to call this folder element, just to make it probably a little more clear. So we're getting the folder element, and then we're checking its name, and we're checking it. Now what we want to be able to do is we want to be able to keep going down through all of these and check any of the ones that are inside of it as well. So what we need to do is, like we did before, is we need to recall the create directories from XML, and we need to pass it a root element. In this case, it's going to be the current one that we're inside again. So now what we should be able to get when we run this is clear that. let's print some of this stuff out. So I'm going to say print folder name, for instance. And I'm going to grab all that and run it. So now we should get all of them printed out in order. So there's assets. And inside of assets, we have model scenes textures. So model scenes textures was printed next. It then went on to renders for us, and then did previews, finals, then animation, scene 1, and shot 1, which was inside of it each time. So we have a recursion happening now for each of these. So what we can do now is we can actually go in and we can start concatenating and putting together a directory system, and we can use make dir and make that directory each time. Now what we need to do is we need to make sure that we're adding on to this directory and building up a directory system that we're going to be able to add these files onto and remove files from. So now what we want to do is we want to be able to build up a directory system and a folder path. So we're starting in this location. We need to be able to pass this on. So each time we call create directories, we're stepping another folder into, or another element in. We need to be able to build up and know which folder we're inside of this as far as a path goes for building our directory system. So in this case, let's add to our function just another, I want to say location colon, and I want to pass it just an empty string to start with. And when we start this off, we're going to say location colon, and I want to pass location again, which is the actual name of it. So this is the location string, basically. So we're going to pass this in, and let's just do print location. Now we want to pass that location along each time and add to it as we go. So I'm going to say location and colon, and let's concatenate together each of our folder names that we're building along the way here. So what we want to do is we want to say location, our string that was passed to us, plus what? Well, we need those double backslashes in between the last folder and the next folder. And then we need the folder name property that we've got picked up that's actually listing the folder name. And we're going to pass that along. So if I run this now, forgot to put another plus sign in there. And looks like I've got another mistake in there somewhere. Location plus. Location. Oh, let's put brackets around this. So we need to put some parentheses around this to make sure that we're not just getting the first part, because it's probably breaking off at this point here. So let's grab that and run it, and there we go, it ran. So what it's getting is the first time it gets passed, it's getting past this original location that we sent it here, the Xml Project Manager. We then went one directory deep and we found assets. And assets is being passed 3 times because we're going through each of these, and we're going to build each of these inside of assets. So we're stepping through each one of these, and each time we're going through one of these, it's getting printed that. We're stepping back, and the last iteration of the recursion's running, and it doesn't have assets tacked onto it. And in this case, we step into renders, and there's 2 folders inside of renders that we're printing out at the same time now. And then we're on down to scene 1. And as soon as we get down to scene 1, we've got shot 1 in the end. So what we're doing is we're building up our path recursively here and passing it along for the next iteration of the create directories to use and to work with. So what we could say simply now is, let's call this we're going to use the make dir. So let's go and get make dir here. And we need to make a directory. So step back over and say make directory. What directory we're going to make? We're going to make the full path here where we just made it. So we can grab that. So this is going to be our folder name plus our path. We could check and make sure that it actually makes one, because as we found out, it actually returns true or false. So in this case, it's returning true. So we could check and see if indeed it actually did make it. Should we step on to the next stage of it and do an if test there? In this case, I'm just going to leave it and let's see what happens. So this should be making directories now. So let's run that and let it run through. And when we check, we'll see now that we have folders all down inside here, and we've built these assets on. Now, one of the things we didn't do is we didn't actually put it inside of a folder system. So there's the test one as well. So let me go get rid of those. So we wanted to use this project name as the first one and have it run on there as well, and have this project name running. So let's make sure that we tack it on, and always tack it on to the end of the location as well, and make sure that that name is being placed there. Of course, we could also make the initial folder originally and pass it in as the root as well. So there's a directory system that's actually building, or a recursive function that's actually building all of the files needed, all of the different folders and whatnot from an XML file. I hope that helps.